So hey there guys, welcome to lecture 5 of the Matlab course, Code the Universe. In this week we'll be handling loop and jump statements, and we'll also be seeing about the concept of vectorization, which is something which Matlab and Octave are specialized for and something which is quite important to learn when you are doing mathematically computational programs. So well, in the previous class, you learned about some of the initial kinds of control statements like if and switch, which execute a certain set of commands based upon whether a condition is true or not. Well, what a loop is that it repeats a set of statements again and again based on some condition. And there are two kinds of loops in MATLAB that we generally use. One is the for loop and the other is the while loop. Jump statements in specific are statements which help you manipulate and go around an iteration or a loop completely. So, well, let's start with some examples of how a loop is and then we can get to it. So you also learned in the last class that we generally don't do everything from the command. We use scripts to do things. So well, for this class I've written a few scripts for us to use, for us to actually learn what these loops are. So let me just get to them. So well, the first kind of thing that we'll be dealing with in this class will be the for loop. So before I give you a clear program about how the loop works, let me just explain how the syntax for this. So for is the keyword by which you're going to denote this. For vector, let vec be some vector, or for I is equal to this vector statements. All right, so for the value of I being among the values of the vector, these statements are executed. So how this works is that, let's say I have a certain vector here, something like 1:10. Okay, so for every time I takes a value from the vector, the statements below are executed. So when I takes the value 1, the statements are executed, and then the value of I turns to 2, and then the statements are executed again, and then the value of I turns to 3, and then the statements are executed again, and it carries on until 10. So this vector over here, it can be given in this vector building form using a colon, or it can also like this, or it can also be a predetermined vector which is of your choice. For instance, let me say I need a vector like 1, 2, 7, 8. Well, it can be anything like that, but in this case the difference is that it won't be in a sequential order. So it will be I is equal to 1, statements are executed. I is equal to 2, statements are executed. I is equal to 7, statements are executed. And I is equal to 8, statements are executed. So that's how this syntax works. So well, I've written a simple for loop program for you to further understand this. So what we're going to be doing is that we are going to be printing the factorial of numbers from 1 to n, where n is an input that we get from the user. So as we do it usually, we're just going to get this value n as input from the user using the input function. As you see, we give the prompt as enter the number till which the factorials are needed, and then we're going to floor the number. Well, the flooring is just like kind of a safety option, because let's say the user is prompted to enter a decimal. Well, then, that might crash it when we go for declaring this control is equal to 1:n. So we just floor it to make sure that the value is an integer, so that it is compatible with the loop. And then while coming to the loop, we're going to give this value control, CTR. So CTR is just another way of denoting that loop variable. There are different things that people use all over. Some people use CTR, some people use I, some people use J. All these are different ways of denoting how things can happen. How this variable can be used inside the loop. So let's say if I use I is equal to 1 is to n, then I use the value I inside the loop if I want to call that controlling variable. If I use CTR becomes a variable. So it's just, that the variable name can be whatever you want, and it isn't constrained to either CTR or I or J or K or whatever you use over here. So what we're going to do is fprintf, our handy printing function, is the factorial of %f. That's a format, and we're going to give the values of the controlling variable and the factorial of the controlling variable. And if this executes successfully, we'll be seeing an end of the program statement also in our command. So let's go ahead and execute that. Simple for, let me say I need the factorial still 13 or something like that. Then here we got it. So the factorial of 2 is 2, factorial of 5 is 120, factorial of 9 is 3628880. Well, that list keeps continuing like that. Well, we see that here everything is given to precision of around 6 significant figures. That's because I use %f, but if you want it just as, an integer, you can always give %d here, which is a format for that. Let me run that again for sake of clarity. So here we see that, you see everything as integers instead of those high precision floating point numbers over there. All right, so, well, that is the for loop for you. Some of the other ways of that people understand for loops best is by doing some introductory programs that are meant to get you familiarized with the concept of for loops. One of the best ones of those are the patterns programs. So what these are that, using the for loop, you're just going to be generating some pattern. But anyways, before I go into that, let me get you with the concept of what nested loops are. So if you're going to have a loop inside a loop, then that is called a nested loop. So let's say I'll just open a patterns program here to give you an example. So here I have for I is equal to 1 is to 10, and for j is equal to 1 is to I. So what will happen is that I will take up the value of 1, and when I takes up the value of 1, this loop will be running inside for each time that j is equal to 1 to I. And then once the whole set of iterations for this j is complete, I will take the value of 2, and then again this whole thing inside this loop will run. And then, so the process happens 2 times, and for every value of I, a whole set of iterations of j take place, and then I gets updated. So that's how it works. So let's actually get to printing some basic patterns using the loop and understanding the logic of how that actually works. So let me just edit this program a bit to get this a bit, yeah. So here's a program, and well, instead of explaining what it's doing, I'm just gonna go ahead and I'm gonna run it from the command so that you see what the output is, and then I will explain what it does. So you see that it's kind of printing a triangle where the first row is 1, second row is 1, 2, third row is 1, 2, 3, fourth row is 1, 2, 3, 4. How is it doing this? Let's just, take a moment to go through the loop and kind of see and understand how the iteration takes place. So let's say first value of I is 1. For I is equal to 1, it enters the loop. So for j is equal to 1 is to I, which means that it's 1 is to 1, which is only one value. So for j is equal to 1, it goes to fprintf, where it prints the value of j, which is 1. And then it gets out of this loop because j is given only for one value, that is 1. And then it encounters this statement over here, and it prints fprintf is equal to /n, which is just the escape sequence for line feed. And then, well, since we've encountered the end statement, which is the end of the loop, it goes back again here, it updates the value of I to 2, and then it goes back here, and then the value of j becomes 1 to 2, which means that it will execute this fprintf for 2 times, that is for j is equal to 1 and for j is equal to 2. And as you can see here, it prints 1 and 2, and then it encounters the end of this loop again, and then it goes out, and then it goes to the next line, and so on. You can see that this pattern is printed that way. Well, I've given it for I is equal to 1 is to 10. Let's say I give it for I is to 20, and let's just try that out. Well, now it's printing out the same pattern, but till 20. So you see that the number of iterations is what is controlled by this controlling variable. And you've also seen that this controlling variable can be used inside the body of the loop successfully. And well, I hope you've also got the syntax for how this works. That is, that you give a for, you give an end, and then in the middle you give the statements which are associated with the loop. So that's the concept of for loops for you. So let's go on to the while loop. Let me just start up a new script. Yeah. So we saw in the for loop that it's based upon a variable being in a vector. Well, the while loop is much more simpler. It's just that while condition statements end. So when you studied if statements, you understood that the if statements are based upon a certain condition, and that condition has to evaluate to true if the set of statements inside that block is executed. Well, the while loop is just the alternative form of that in terms of a loop. It's just that, while this condition which we give over here is true, these statements are executed. I hope you are quite familiar with the topic of Boolean evaluation by now, and how we use logic to evaluate whether this condition is true or false, or in that case, true is sometimes also represented as 1 and false is represented as 0. So again, let me go with an example of a while loop to show you how that works. So here we're writing a program to declare a number and then keep dividing that number by 2 until it's greater than 1. So my value here is x is equal to 1000, and while x is greater than 1, I'll be dividing x by 2. Okay, so this is the body of the loop. X is equal to x divided by 2. So I'll be having the value of x every single time, and then finally whatever the value is, I'll be printing out that value. Well, this might not exactly have any realistic value to you because it isn't something that you might, generally do when you're programming for an application or something. But it's just to give you an idea of how this loop works and how usually a condition is. So let's just run this and see what happens, and then I'll explain to you how this works. So yeah, that's simple while. The value of x is 0.976562. That's what it's giving us. So let's decode how this program works. Well, so the value of x is 1000. So while x is greater than 1, it substitutes the value of x over here. That is, x is 1000. So yes, 1000 is greater than 1. So we'll go in and it will have the value of x. So then the value of x will become 500, and then again the value of x will be 500, which is greater than 1. So it will run the loop statements again. So 500 will be halved again. It will become 250. This will keep going on and on until there is this particular value of x that is greater than 1. Okay, and when that value of x which is greater than 1 is reached, it will go to x is equal to x by 2. But when that value of x drops below 1, it just exits the loop, comes over to the fprintf statement, and it prints the value. That's how the while loop works. So again, there are other things like, let's say you can even have nested while loops and stuff like that, but I'm not gonna be showing you a program with nested while. I'll just let you know how the syntax is here. Well, let's say something like greater than 1, then some statements here. So let's say, you needed to do this for two separate evaluations for every time that x goes in here. You have a condition that some number is greater than 1, and based on that, these statements are executed, and this whole loop runs inside. It's again how we studied in the for loop. This x is given a certain value, and once it's ascertained that value, this while executes all the iterations or all the statements, all the iterations of this particular while loop are executed, and then it goes back outside, okay? So for every time that x takes a value, a set of iterations are executed for this while loop here, and then it goes out. So that's just, reinforcing how nested loops actually work. So let me show you this interesting program of a interesting challenge that, well, we use loops to work out. So here is a program to find out the Armstrong numbers between 100 and 1000. Well, you might be wondering, what the hell is Armstrong number? Well, here's what that is. So if the sum of the cubes of the digits of a number is equal to the number, then that number is said to be an Armstrong number. Well, let me give you an example here. Let's take just some arbitrary number here. Let's say I take 371, or 371, yeah, is equal to if 3 cubed plus 7 cubed plus 1 cubed is equal to 371, then that's an Armstrong number. I'm not sure if that's true. Let me just maybe do a calculation or something, or let me just do something actually. I'm just gonna go here and Armstrong numbers. Let's get some Armstrong numbers. Yep, 371 is an Armstrong number. So, yep. These are also known as narcissistic numbers, which I don't know exactly why they're called so, but then it's just an interesting, program which we usually do for starters to understand how these loops work. So here's what we have to do if we are gonna find these Armstrong numbers. Remember that when you're gonna write a program for some application, you just don't, just open a program, just, start typing everything. You kind of think about it and how it usually is supposed to be done inside your mind. You get the idea of how you're gonna do it, and then you do it. So I've kind of given the steps right here. So, well, the first step that you're going to be doing is to split the number to its digits. So, well, you'll be doing that. And after that, you'll be collecting the sum of the cubes of those digits in a variable. And then you'll equate that variable with the original number to check if that's an Armstrong number. So we're gonna be seeing only for 3-digit Armstrong numbers. You can also customize this program such that you can just enter a value and then check whether it's an Armstrong number or not. But I'm just going ahead to, use one more loop to show you how nested loops also work from within the same program. So, well, let's see what happens. For num is equal to 100 to 999, whatever, it takes a value of num is equal to 100 first. It goes inside, and well, what is this block of code exactly doing? It's declaring a variable sum is equal to 0. So sum here, to be more specific, isn't just sum, it's sum of cubes. So, well, if the variable name is sum of cubes, well, that will be more descriptive, but I've just gone ahead and just declared it as sum for the time being. So, and then you're going to be having a variable store val. So what store val is going to be doing is that it's going to be storing the value in number. And why exactly are we doing this? Because here in the while loop below, what I'm doing is that for number is greater than 0, I'm changing the value of number each time I go through that. So when this loop ends, the value of number is not going to be the same as it was. So if I'm going to go ahead and, do the final step of equating, well, it's not going to work because number is going to be something completely different than what it was when the loop actually started. So let me run you through the concept of how the digits are split. Now that we've got the sum and now that we've stored the value of numbers safely in our variable store val, what we'll be doing is that we'll be getting digit as remainder of number divided by 10. So let's take our example number here, 371, right? That's our trustee number here. So 371. Okay, if you're going to be dividing this by 10, then what will be your remainder? That's what the remainder function here is going to be giving you. So 371 divided by 10, well, gives you the remainder as 1, because 370 is divisible by 10 and it's going to leave a remainder of 1. So your remainder of 1, so the first digit that's going to be going will be 1. So what you're going to be doing is that the sum plus equal to, plus equal to is the shorthand for saying that sum is equal to value in the sum plus digit cubed. We're going to be giving 1 cubed, which is 1 itself. So now the value of sum will hold 1. So, and then what we go do is that we're going to be dividing number by 10. Well, that means that if you're going to divide 371 by, let me just denote that here in the comments. So 371 divided by 10 in an integer value will just give you 37. Okay, to make sure that it's the integer that we want, we just floor the number again, which is our trusty function for making sure that a float is converted into the integer. So yep, that's what happens. And then it encounters the end, so it goes back to the start here. And well, the number 37 is checked for whether it's greater than 0. And well, yes, 37 is greater than 0. So again, it's divided by 10 and the remainder is obtained. Well, the remainder is, in this case, that will be 7, because 37 divided by 10, 30 is divisible, so 7 will be the remainder. So digit will be 7, and then again 7 cubed will be added to the sum, and then we'll be dividing number by 10. So now the value will be 3. So let me just write that out. The next digit from 371 is 7, which is taken into our program. And then what we're doing is we're going to divide 37 by 10, which is going to give us 3. So 3 is again greater than 0. We'll go inside. Well, it's going to be dividing 3 by 10, looking for a digit, which it won't get. Well, I'm sorry, it's actually dividing. Yep, it's trying to divide 3, so it's not getting that digit. So it's just going ahead that it can divide. So the digit will be 3 in this case, because it wasn't even divisible. So that will be used in the sum, because the remainder function doesn't do any work here, because what you're trying to do is that you're going to be trying to divide 3 by 10. That's not going to work. That's just going to return you 3. And then it'll go for 3 cubed, and will it add it to sum, and then it will again divide the number by 10. This time the division is not going to work. It's just when you floor it, it will be 0, because it will return something like 0 point some number, because the division, if you're going to divide that value by 10, you'll be getting some decimal like that, and when it's floored it becomes 0. So when number is equal to 0, it is not greater than 0. It's just it's just equal to 0. So the loop will stop. This part won't get executed, and we'll be going to this if over here. Okay. So sum now contains the sum of the cubes of the values 3, 7, and 1. And we're going to be equating it with the value in store val, which is our trusty locker for the value, the original value of number. And well, if this condition is satisfied, it will display the number. So well, that is the end of our long Armstrong number program. Let's see if this works. Armstrong. So well, that gives us the 4 possible Armstrong values between 1000 and 999. That is the 3-digit Armstrong numbers are 153, 370, 371, 407. Let's just go ahead and test any of these values and check whether the output is actually right. So 1 cube plus, I'm just doing this manually to verify whether my program's right, plus 3 cube, that's equal to 153. So, well, our program has done its job perfectly, and it's given us the Armstrong numbers. All right, let's move on to the next section of what are we doing now. Okay, now we'll be studying what jump statements are. So what jump statements are that there are a way to manipulate loop. Well, let's say you don't want a particular iteration of a loop to happen, or if some condition occurs, then you want to actually get out of the loop. So break and continue are those two statements. So let's kind of see the syntax of how these actually work. So let's say for vec is equal for, sorry, I is equal to vector statements 1 if condition, some condition for that scenario, break statements 2. So this is how you give it. So in general, it's not necessary that this break statement be in the middle of an if condition, but that is the usage of the break statement. In the sense, it's not mandatory, but that's how you're going to use it. Because the reason why it's given like this is that, so let's say for I is equal to some value, it comes inside, it will execute all the statements 1 which are above this condition, and then it will go to this if statement and it will check if condition, and well, if this condition evaluates to true, it will go to this break statement, and once it encounters this statement, it's just getting the hell out of this loop. It's not doing anything, it's not touching statements 2, it's not going back and doing another iteration, it's just getting out, it's just forgetting that the loop ever existed. So whatever happened till there happened, once the statement is encountered, it gets out of the loop. Okay, so let's actually look at a program where I've used this. Well, here that program is. So we're going to be finding the prime numbers from 10 to 100. Okay, the reason you might wonder why why it isn't 1 to 100 and why it's 10 to 100 is that when it goes in the range 1 to 10, some values like 2 have some exceptions and stuff, while doing this process of checking for prime numbers. If you have done that program already, you'll know. But for the time being, let's just look at the prime numbers that exist from 10 to 100. Okay, so the first thing is I'm gonna be declaring a variable called flag. Now, if you don't understand why I'm doing this, just wait for till the next part of this program and you'll understand this. Okay, so for while, I'm sorry, for check divisor is equal to 2 is to floor of n by 2. So again, if this doesn't make any sense to you, let me just explain this to you. So a prime number is a number which isn't divisible by any number except the number itself and 1. Okay, well, that being said, what we're gonna do is that using this variable check divisible, we're gonna be checking whether this number is divisible by checkdiv or not. Okay, well, maybe checkdiv isn't the best name that I could have given this variable, but it just made sense because I'm checking whether number is divisible by checkdiv. So that's what I'm actually doing. So you might wonder why I'm not giving floor n and floor n by 2. Well, that's just simple practical logic. Okay, so think if you're going to be handling prime numbers, well, the highest number that a number will be divisible by is half the number. Okay, because that's just dividing it by 2, and after that it's not really necessary that you check whether it's divisible for numbers above the value n by 2. So, well, you can give it like that. You can give something like n minus 1 over there, But then you'll just be wasting some computational efficiency because, it's going to have to run more cycles when that's actually not needed, right? So anyways, what's happening is that for every particular value in this list, 2 is to floor n by 2, it'll come inside here, and if that remainder is equal to 0 when the number is divided by this check div, then the flag will be changed to 0 and it'll trigger the break. So what happens is that if this is happening, the break will just take it out of this for loop which is inside, okay, and it will come to the outer for loop which is here, okay. So now if the value of flag is 1, then it displays the number. And why is that so? Well, this is because what is happening here is that for every time that checkdiv takes a value, this is actually checking whether it's divisible or not. And if it finds out that this number is divisible by some other number in this range, then it understands that it's not a prime number, so it equates the flag to 0. So the flag to 0 is our way of signaling or having an identification that that particular number is not a prime number. So we're initially assuming in this statement that flag is equal to 1 or the number is a prime number. And if this is false, then this loop checks that out for us and it lets us know by signaling that flag is equal to 0 that it happens. And now that it has found out that that it's not a prime number, it will get out of this loop because its job is done. Its job was to find out whether divisible by some other number or not. Well, its task has ended, so it's just getting out of this loop. And here it comes to this if statement now, and if flag is equal to 1, then it displays the number. And well, that's the end of this program. Well, you might be wondering what this part is. This is something which I just wrote to explain the concept of continue to that for you guys. Let me just comment that code out and let me just run this to show you how this works. Just a second here. Okay, break and continue, is it? Yep. All right, what was that? Whatever. Oh, it's in a pause. Okay. All right. So you see that, well, you might be wondering why my cursor just actually broke down and didn't display anything, because there is this pause statement here, which means that only if I press a key to continue, it will resume again from there. Actually, this pause is supposed to be here. In case I haven't yet covered the pause statement in any of our lectures, well, that's the pause function for you. Surprise interim lesson in the middle of a lesson for break and continue. Well, anyways, look here, 11, 13, 17, 19. These are the prime numbers between 10 and 100. And well, the break just did our job successfully for us. So now that this is done, let me just go ahead and explain continue for you. What I just explained was break. Now, what is continue? Now, let's say that you want to get out of the loop for one particular iteration, but you want all the other iterations to continue. Okay, if you don't exactly get what I'm trying to tell you, let me first give you the syntax and then we'll discuss how this works. Right, is equal to vec statements 1 if condition continue oh god yeah. Statements 2. Okay, so this is how that works. Okay, so for if I is equal to any value in vector statements 1, if this condition evaluates to true, it'll go here and it will encounter this continue. So what happens is that it neglects all these statements, which are denoted by statements 2 here, and it will go ahead and it will enforce the next iteration of the loop. So let's say for I is equal to 1, we go in and let's say condition if I is equal to 1, something like that. Something like that is given, then what will happen by this continue statement is that it's said to neglect all these statements here in statements 2 if the value of I is 1. So what it will do is it won't just get out of the loop, but it will enforce the next iteration. Well, let me just show you one particular purpose where I might use something like this. So break continue, the first part of this program. Let me just decomment all that stuff. Okay, yeah, my screen just freezed for a second. I'm so sorry about that. So, well, for I is equal to 10, I'm sorry, 1 is to 10. If I is equal to 8, continue, end the if, and then go for the f printf, and then have the end. So, what's happening here? For every value of I from 1 to 10, it's going inside, and this statement over here is telling it to print the square of I is I square. So that's what it's happening. It's just printing the squares of numbers from 1 to 10. That's a very, very basic program. So what I'm telling it to do is that if the value of I is 8, then I'd not want it to print the square of 8. So let's say you want to print the squares of numbers from 1 to 10 except for the number 8. Then that is one kind of particular simpler scenario where you'll actually be doing the job of using a continue. But anyways, let's just go ahead and check if our program is actually working. Well, it is. Square of 1 is 1, 2, 3, 4, 5, 6, 7. Well, as you see, 8 is missing, so, well, it's worked successfully. I'll just get out of that program. So I hope that kind of clarifies the concept of jump statements for you. So the final concept that we'll be dealing with today is vectorization. How I love to call this is that, the definition of vectorization is don't use a loop if you don't need to use a loop. In other words, putting it very, very simple, Matlab and Octave are languages that are made for matrix and vector computations. And sometimes you're able to take the concept of matrices and vectors to your advantage and use them instead of loops. What I mean is that operating upon matrices and vectors are highly efficient when we compare it in terms of computation. When we compare it with loops, on the other hand, well, the difference can be very, very drastic, up to 40 times of a minimization in time. Well, you might not really realize it when you're doing a very small program, but when you're handling huge programs, especially from my experience as a person using MATLAB for applications like machine learning, I can tell you a loop can take up to 2 hours for a job that a matrix computation can do in just 2 minutes. So it will be a humongous waste of both your memory as well as your time. So using vectorization is one of the best things that you can do. There are several examples of where you can use vectorization, but well, let's just encounter a very simple example of how to do it. Well, you saw in the break and continue section that I wrote this program to compute the squares. Let me just copy paste this. Well, so what I'm doing is, let me just also take out this continue block. For I is equal to 1 to 10, um, I'm printing the square of the number is using a loop. Do I need to do this? Do I need to iterate? Do I need to take a variable I, iterate it through all this value? Every time I has to get assigned in the memory, and then again it has to execute this printf. It has to match these values with the formatter. every single one of these operations is a part of computation. And if you can minimize all that stuff, well, hands down, here's the way you're going to do it. So here, what you're going to do is you're just going to put this a vector called num squared or numbers squared, and it's going to be equal to 1 to 2 element wise squared. Okay, so by doing that one single statement, you'll be avoiding this entire computation. And look at it, okay, it's just, one line that solves the whole purpose for you. Instead of having this 3-line code do it, you're just doing the whole thing by a more simple, more aesthetic way of doing it. Well, here the difference might not seem very big to you, it's just 3 lines, you might be like, I might as well, just type 3 lines. It's not a big deal for me, but when it comes to bigger programs, trust me, the difference is huge. All right. So anyways, that small talk aside, let me just go ahead and vectorization. Well, I just got my values, as simple as that. Well, what if, I execute the loop. Okay, just a second. Yep, so what I'm doing is that I'm just, giving you an alternative of how this works with a loop. Well, it still works, and well, the output is formatted. Again, if you wanted to do it, you could use vectorization and then format the output like this. But the thing is, both ways, you're getting the same output. It's 1, 4, 9, 16, 25, 36, 49, 64, 80, 100. Again, it's 1, 4, 9, 16, 25, 36, 49, 34, 64, 80, 100. It's the same values, whether or not you do it this way or that. Let me just give you a few more examples of how you can do vectorization. In fact, let me just say for equal to 1 to 10 factorial of I. Well, let me run this program now. Well, I know the output isn't formatted and it looks clumsy, but here it is. It's giving you the factorials of numbers from 1 to 10. Do I need to do this? No, I don't. All I need to do is factorial. Let me just say I'm gonna give a variable like factorials of 1 to 10 is equal to, let me just give a vector 1 is to 10 here, and let me actually do this as factorial. I'm just passing the entire set of values to a factorial function. Let's see what happens. Well, it's still the same output, it's just 1, 2, 6, 24. So what I'm trying to say is, by giving you all these examples, is that these are simple one-line implementations for all these computations where you will be prompted to use a loop, but you don't actually need to use a loop. Well, let me tell you the most common scenario where I find people not using vectorization and instead going for loop-based implementation. Well, the thing is that you might have learned some other language, like say C++ or Python or Java, where you would have certainly worked around these kinds of things with the help of loops. So the natural thing for you is that once you know that there exist loops, you'll just tend to use them. You're just like, okay, once when I tell you you're gonna have to do factorials, the first thing which will pop out in your mind is, okay, I'm going to find a factorial, I'm going to use a loop, I'm going to do this, I'm going to do that. Well then, you got to mend your way of thinking if you're going to be doing MATLAB, okay? So if you're going to be doing MATLAB, you need to know to use these vectorized implementations to the best. Well, anyways, I did make a statement just a few minutes ago that, if you came from a language like, Python or C++ and then started learning Octave or MATLAB, you might, have the idea of tending to use these. Well, of course, vectorization libraries do exist in those languages too. But I'm talking about the basics in this sense that in the basics you're just taught how loops are, and then you're asked to do loop-based implementations. Well, you should always prefer computationally efficient methods. So revising what we just learned, we learned about for loops, while loops, nested while loops. We went through this unique program called Armstrong, where we compute what Armstrong numbers are, and then we saw a beautiful pattern being printed using the pattern function, and then we learned the concept of vectorization. Well, that brings us to the end of this lecture.